Oh, okay. Good morning, everybody. It is 4:32 a.m. on November 7th. Um, um, I've been all night awake doing random stuff. I don't know, but might as well get this project over because I was bored. So we are graphing a function. This function in specific, x squared minus 2x minus 8 over x squared plus 3x plus 2. So the first thing we do, we will be factoring the equation or function. So the top becomes x minus 4 times x minus 2 over x, actually no, I lied, x plus 2. And the bottom function becomes x plus 1 times x plus 2. And before we continue on, we actually have a hole in this function. Whenever to know if you have a hole in your function, you need to figure out if you have the same factor on both top and bottom. So I'm gonna create a layer right here to highlight that for you. So we have x plus 2 on both top and bottom of the function. So we will get rid of that. So our equation will become a baby equation. So it becomes x minus 4 over x plus 1. So actually, since we are graphing, so we need to actually figure out where our hole actually is. So how I got this -2 is that you will set this factor that we just got rid of to 0. So x plus 2 equals 0. To get x bad stuff, you minus 2. So x equals -2, and that is the x part of our whole coordinate. And to find the y part of our whole coordinate, we will get this x2 and put that into x right here. So it becomes -2 minus 4 over -2 plus 1. So it simplifies into x into -6 over -1, and simplifies even more into just 6. So that we just got our coordinate for our hole. Okay, we will actually keep this baby equation in hand because we will be using it later in a bit. So back to here, we have our hole. Let's find the x-intercept. To find the x-intercept, you will be setting the top, in this case the left, but it's the top, to 0. So it will becomes x minus 4 equals 0, and it will become x equal 4. Because to get rid of -4, you plus 4, blah, blah, blah. You guys know that shebang. And we will actually write this in a coordinate also. So this will become 4, 0. And that is our x-intercept right there. So we will be finding our y-intercept. And to find the y-intercept, all you gotta do is set every single x in the equation to be equal to 0. Oh wait, no, not equal. Every single x to 0. So it doesn't matter if it's factored or not. You could use this equation, but in this case, I'm not an insane person, so I will be using our baby equation over here. So this will become 0 minus 4 over 0 plus 1. And it will simplify to become minus 4 over 1. And simplifies even more to become minus 4. That is our y-intercept right there. So our y-intercept is y equals -4. Converting that into a coordinate will be 0 minus 4. That is our y-intercept right there. All right, let's find the vertical asymptote. And to find the vertical asymptote, you will set the bottom to 0 to equal 0. So in this case, our bottom is x plus 1. So x plus 1 equals 0. That will be our vertical asymptote. So x plus 1 equals 0. convert that to x equals minus 1. Now you do not, for asymptotes, you do not need to put them in coordinates, but you will need to be careful with having to put x and y equals. For vertical asymptote, it is x equal. For horizontal asymptote, it will be y equal. So that is our vertical asymptote right there. Let's find our horizontal asymptote. And to find the horizontal asymptote, you will utilize Bobo button HDC. Bobo is bigger on bottom, and bottom is bigger on top, and each DC is equal on both top and bottom. In this case, in our function, we have each DC because our degrees are both equals in top and bottom. So what we do with each DC is we divide the coefficients, and you may look and you don't see any coefficients over here. It's like, oh no, where am I? Okay. That is actually invisible ones. So this will become 1 over 1 equals just 1. But converting, because this is an asymptote, it will become y equals 1. And that is actually all we need to graph this function. Okay, let's start graphing because I need to go to work. Negative 2 and 6, that is where our hole is. So 1, 2, and 6 is up here. So right here. Holes need to have need to be open circles because, you know, they're holes, you know. Haha, funny. Okay. Back to next one. X-intercept. Our x-intercept is 4, 0. So 4 to the right. 1, 2, 3, 4. This is where our intercept is, or x-intercept is. You know, let's label this because I don't want to have terrible handwriting. Okay, and our y-intercept is 0, negative 4, so down 4. 1, 2, 3, 4. This is our y-intercept right here. And our vertical asymptote is x equals negative 1, so 1 back. So it is right here. Wait, hold on. There we go. Okay, boom. Now we will graph our h asymptote, well, horizontal asymptote, is y equals 1, so up 1 right here. 1, 2, up, I like to count. Okay, that is our thing. Now we just need to put in lines, and luckily for us, both of the intercepts are in one corner, so we know our line needs to cross. Hold on, that is a terrible line. That's still terrible. Okay. Needs to cross like that. Something like that, yeah. Cross like that. And our hole over here, because the other side needs to always mirror. And for holes, you always need to go stop at the hole and continue the other side. Hence, it's called a hole. And I think that is it. That should be it. I'll label it x equals minus 1. And our asymptote is y equals 1. And our x-intercept, why is that negative 4? I don't know why. Hold on. Okay, 4. 4, and our y-intercept is negative 4. Boop. Okay, that should be it. Right, well, thank you for watching, and I will be going to work now.